Hi students, now I am going to explain you some important named reactions in organic chemistry which are very important and useful to crack NEET as well as IIT JEE. Okay? So, the named reactions in organic chemistry, to start with, the first one is Wurtz reaction. In Wurtz reaction, two alkyl halides, they condense, they couple in presence of sodium metal in the solvent anhydrous ether to give alkane. Okay? A similar reaction is Wurtz-Fittig reaction. This is also coupling of one alkyl halide and other aryl halide, okay, in presence of sodium metal in anhydrous ether, then you will get the corresponding product. This is alkyl halide, this is aryl halide, and the product is alkyl benzene. The product is alkyl benzene. Okay. Another similar reaction is Wurtz-Fittig reaction. Okay. Here coupling of two aryl halides will take place in presence of sodium metal, and the solvent we use is the anhydrous ether. So, you can see the two aryl halides coupling and the product is biphenyl. The product is biphenyl. Okay. Now, we have a question on this which was asked in NEET 2023. The question is, they have given acetaldehyde. Okay. This is subjected for reduction with lithium aluminum hydride followed by hydrolysis. So, the product you get is ethyl alcohol. Ethyl alcohol, A is ethyl alcohol. Ethyl alcohol on dehydration with sulfuric acid, okay, you get ethylene. This ethylene on treatment with HBr, C is ethyl bromide. Ethyl bromide is alkyl halide, bromobenzene is aryl halide. It is a Wurtz-Fittig reaction and the product is ethyl benzene. Okay. 3 is the right option for this answer question. Okay. Answer 3, that is ethyl benzene. Okay. Next, you have one more question. Which of the, this was asked in NEET 2020. Which of the following alkane cannot be made in good yield by Wurtz reaction? Usually, symmetrical alkanes can be obtained in good yield by Wurtz reaction. So, if you observe the products here, N-hexane, 2,3-dimethyl butane, N-butane, these are symmetrical alkanes, whereas N-heptane is an odd numbered compound which cannot be prepared in good yield. So, the answer is 3, which cannot be prepared in the good yield is N-heptane by Wurtz reaction. Okay. There is one more question. Hydrocarbon A reacts with bromine by substitution, okay, to form an alkyl bromide which on undergoing Wurtz reaction is converted to a gaseous hydrocarbon that contains less than 4 carbon atoms. Okay. So, the alkane, the hydrocarbon is reacting with bromine by substitution. So, these two are unsaturated compounds, they undergo addition reactions. So, 2 and 3 are not the correct options. It can be either 1 or 4. Now, suppose if this compound is forming a bromide, that is ethyl bromide, and this is subjected for Wurtz reaction, the product is N-butane which contains 4 carbons. But what is saying, it gets less than 4 carbon atom product is formed. So, obviously, it has to be methane. So, methane will form methyl bromide by free radical substitution. This will undergo Wurtz reaction and the product we get is ethane. So, the answer is 4. Okay. Like this you have to answer. Now, the another interesting reaction, important reaction is carbonyl group can be converted to methylene group. This is the carbonyl group converted to methylene group by using zinc amalgam in HCl, which we call as Clemenson's reduction, and there is another reaction in this reaction also carbonyl group can be converted to methylene group. This is Wolff-Kishner reduction. In this reaction we use hydrazine followed by reaction with KOH and ethylene glycol. Okay. Now, we have a question on this name reaction. Here identify product A in the following reaction. So, in this reaction we have two carbonyl groups, there is a Clemenson's reducing agent, is a Clemenson's reduction. Now, what happens is this will be converted to methylene group, this is also converted to methylene group. So, here if you observe the options, option 3 is correct. Okay. You can see option 3 is the right one for this particular question. Okay. Next, Kolbe's electrolysis. This is also a very useful method for the preparation of alkanes. So, here what happens is, if you take aqueous solution of sodium or potassium salt of carboxylic acid, subject it for electrolysis, then what happens? There will be formation of alkane at anode and carbon dioxide is formed at cathode. Here also there takes place coupling of alkyl groups. Say for example, if you start with potassium ethanoate, okay, you are taking two molecules. Now, when they are subjected for Kolbe's electrolysis, these two will couple and the product will be ethane. Okay, the product is ethane. Okay. Now, another reaction, soda lime distillation of carboxylic acid. In this reaction also the starting material is the carboxylic acid only. You take the sodium salt of carboxylic acid, treat with the soda lime, that is a mixture of sodium hydroxide and calcium oxide. In the process, the product you get is alkane. The alkane will have one carbon atom less than the starting parent carboxylic acid. Okay. So, this is the sodium salt. Okay. Now, you are subjecting this for soda lime distillation and you got this product. Say for example, here you have started with sodium ethanoate. Okay. This is sodium ethanoate, a 2 carbon containing acid. The product you get is methane, 1 carbon containing alkane, 1 carbon will be less in the product. So, this is nothing but soda lime distillation of carboxylic acids. Okay. So, here an interesting question based on this soda lime distillation of carboxylic acids. What is asking? Weight in grams of 2 moles of organic compound which is obtained by heating sodium ethanoate with sodium hydroxide in presence of calcium oxide. So, sodium ethanoate, this is sodium ethanoate subjected for distillation with soda lime, you get methane. So, 1 mole of this starting material will give 1 mole of product. What is the molecular weight? 16. Okay. Now, he is asking 2 moles, that is 32 grams. How many grams of methane are formed? 32 grams. So, the correct option, the answer is 4 for this question. Okay. Next, Sebecher-Sandrens reaction. It is a hydrogenation reaction of unsaturated hydrocarbons which involves a syn addition. See, you can see, if you use alkene, we get alkane, it will consume 1 mole of hydrogen, and if you take alkyne, it will consume 1 mole to form alkene. Upon addition of another mole of hydrogen, you will get alkane. So, this is a syn addition. Hydrogens which are adsorbed on the nickel will come from the same direction and add on to the double bond. Okay. Next, Friedel-Crafts reaction is a very useful reaction in the aromatic chemistry. Okay. Here the reaction is benzene is treated either with alkyl chloride, okay, or acyl halides, alkyl chloride or acyl chloride. Then what happens? In the presence of a catalyst anhydrous AlCl3, either you will get alkyl benzene or acyl benzene. This is a very important reaction. If you get alkyl benzene, it is called Friedel-Crafts alkylation. If you get acyl benzene, that is Friedel-Crafts acylation. In this reaction, alkyl carbocation is the intermediate. In the second reaction, acyl carbocation is the intermediate. Acyl carbocation is the intermediate. It is a very important and useful synthetically useful reaction. Okay. Next, this is another interesting reaction. See, if you want to prepare alkyl iodides, it is an exchange reaction. It is called Finkelstein reaction. In this reaction, you may take alkyl chloride or bromide, treat with sodium iodide, the product is alkyl iodide. Okay. Now, there is one more reaction. Here you have prepared alkyl iodide. If you want to prepare alkyl fluorides, okay, then we go for the Schwarz reaction, in which alkyl chloride or bromide on reaction with certain metal fluorides that will undergo halogen exchange, and the product you get will be the alkyl fluoride. Here you have another interesting reaction, that is Balz-Schiemann reaction. It is a method of preparation of fluorobenzene. Okay. Here what is happening is benzene diazonium chloride is reacting with fluoroboric acid, okay, and the product is benzene diazonium fluoroborate, which on heating you are getting fluorobenzene. Okay. So, this is another interesting and important reaction. Next, hydroboration oxidation reaction. This is also interesting reaction. In this method, from alkenes we can prepare alcohols. If you start with unsymmetrical alkene, the product is alcohol, but that is an anti-Markovnikov product is obtained in this reaction. Okay. Now, you observe this reaction, unsymmetrical alkene propene is reacting with diborane. Okay. Now, hydrogen will attack one of the sp2 carbons having less number of hydrogens, will attack the another sp2 carbon having less sterically hindered. Okay. So, this is the initial product. Now, to this another mole of alkene and another mole of alkene are added, you get trialkyl borane is the intermediate compound that is formed, which on subsequent hydrolysis you will get an alcohol, which is an anti-Markovnikov's product. Next is Williamson's synthesis. It is a method of preparation of ethers. Okay. So, here in this reaction there will be a reaction between alkyl halide and sodium alkoxide to get ether. We have a question on this here. Allyl phenyl ether can be prepared by. So, what starting materials are required to prepare allyl phenyl ether? So, let us write the structure of allyl phenyl ether. First of all, CH2, CH, CH2, O, pH. This is allyl phenyl ether. Now, what starting materials are required? Here he has given 4 options, but we know that you require allyl halide or rather allyl bromide plus sodium phenoxide. They couple together, okay, and you get the product. See, here you cannot use phenyl bromide, because phenyl bromide will not undergo cleavage. So, you cannot use phenyl bromide, you have to use sodium phenoxide and allyl bromide we have to use to prepare allyl phenyl ether. Next. So, answer is 4. Okay. Next, phenol on reaction with chloroform in the presence of sodium hydroxide forms orthohydroxybenzaldehyde, that is salicylaldehyde, along with the para isomer. So, here you are also getting a para isomer is also formed in this reaction. Okay, you got here orthoisomer plus, okay, you get hydroxy like this, you also get the para isomer. So, this orthohydroxybenzaldehyde is called as salicylaldehyde, and this reaction is called as Reamer-Tiemann reaction. It is important for you to note that the reactive intermediate in this particular reaction or the electrophile in this reaction is dichlorocarbene, that is CCl2. This is the dichlorocarbene is the reactive intermediate that is that is formed during the course of reaction, which acts as the electrophile. And another such reaction, the phenol, that is phenol is first treated to form sodium phenoxide, because sodium phenoxide is a more stronger, is a very relatively more reactive than phenol, which on reaction with carbon dioxide followed by hydrolysis you are getting orthohydroxybenzoic acid, that is a 2-hydroxybenzoic acid. Along with this, here also you are getting the para isomer, along with orthoisomer you also get the para isomer, and this reaction is called Kolbe's reaction. Okay. Riemann-Tiemann reaction and Kolbe's reaction, these are the two important reactions of phenol. Okay. Next, here is a question. The major product obtained in the interaction of phenol with sodium hydroxide and carbon dioxide. Okay. So, here this is nothing but Kolbe's reaction. So, the product you are getting is the orthohydroxybenzoic acid, that is the salicylic acid. Answer 2 is the correct option for this question. Okay. Next, which of the following represents Riemann-Tiemann reaction? Just now we have seen phenol will react with the chloroform in the presence of base, followed by hydrolysis, you are getting orthohydroxybenzaldehyde. So, option 1 is the correct option for this question. Okay. Next, now the another question, intermediate compound or the intermediate species that is formed in the Riemann-Tiemann reaction. Just now I told you dichlorocarbene is the intermediate that is formed. Okay. Answer 2 is the correct option for this. Next, Stephen reduction, it is a method of preparation of aldehydes. So, you take alkyl cyanides that on reaction with SnCl to HCl, corresponding imine hydrochloride is obtained. That imine hydrochloride on boiling with water, corresponding aldehyde is obtained. You have started with 2 carbon nitrile with 2 carbon atoms, you get aldehyde with 2 carbon atoms. So, this is nothing but one of the methods of preparation of aldehydes, Stephen reduction. Okay. Now, another interesting reaction, preparation of benzaldehyde, Itard's oxidation. Here toluene is treated with chromyl chloride in carbon disulfide to give an important chromium complex. Okay. This question was asked in the previous exams. Chromium complex, which on hydrolysis you are getting benzaldehyde. Okay. And another method of preparation of aldehyde, a named reaction, that is Rosenman reduction, acid chlorides on reaction with hydrogen on palladium in presence of barium sulphate, using the solvent quinoline, you get aldehyde. What is the significance of this reaction? Here the significance is barium sulphate will act as catalytic poison and it prevents the reaction at aldehyde stage only. It will not allow aldehyde to reduce further to primary alcohol, that is reduction to primary alcohol is prevented barium sulphate by acting as catalytic poison. Okay. Next, so here is a question that was asked in NEET 2021, the intermediate compound X in the following chemical reaction is. So, just now we have seen you get a chromium complex of all this is the chromium complex that is given as one of the options. So, the correct option is, that is 2 is the right option for this question. Okay. The next reaction is aldol condensation. Okay. Aldehydes are ketones having at least one alpha hydrogen on reaction with dilute alkali, which is acting as a catalyst. Then we get beta hydroxy aldehydes or beta hydroxy ketones. They are called as aldol or ketol. Actually, here carbonyl compound with at least one alpha hydrogen. This is the alpha carbon, this is the alpha hydrogen. Of course, there are 2 more alpha hydrogens in this molecule. Now, when it is treated with base, base will abstract proton, corresponding carbanion is formed. This carbanion will attack partially positively charged carbonyl carbon of another carbonyl compound. Okay. So, here we are getting CH3, C, H, O minus, CH2, C double bond O, H. This compound on subsequent hydrolysis you get beta hydroxy aldehyde. This is the carbonyl compound, functional group alpha, this is the carbonyl group alpha and beta, beta carbon. So, beta hydroxy aldehyde. In case if we start with a ketone, okay, if we start with a ketone like this, now here you will get beta hydroxy ketone. So, these are nothing but aldol or ketol. Here the important aspect which you have to keep in mind is, if we start with one compound that contain alpha hydrogens, say acetaldehyde only you have taken, subjected it for aldol condensation, you get the product. Or if you take acetone only, that also contains alpha hydrogens, subjected to be subjected for the reaction with that is a dilute alkali, then also you get a product. These are nothing but aldol condensation. But if you take two different carbonyl compounds, like if you take acetaldehyde and acetone, two different carbonyl compounds, both are having alpha hydrogens, then the reaction is called crossed aldol condensation. If you take single molecule, it is normal aldol condensation. Two different carbonyl compounds, it is called crossed aldol condensation. In the crossed aldol condensation, we get 4 products, because we can have the combinations: acetaldehyde forming the carbanion attacking on another molecule of acetaldehyde, acetaldehyde forming the carbanion attacking on acetone, okay, 2. Next is acetone forming a carbanion attacking on acetone, acetone forming a carbanion attacking on acetaldehyde. Like that, in crossed aldol condensation, we can get 4 products. Okay. Next, another reaction, compounds which do not have alpha hydrogens, when they react with a concentrated alkali, they undergo reduction and oxidation. That is, here we have taken formaldehyde. It is a compound without alpha hydrogens, because as such there is no alpha carbon. So, there is no question of alpha hydrogen. Formaldehyde on reaction with the concentrated KOH, it is forming methanol, a reduction product, and potassium formate, an oxidation product. Okay. So, you can take some of the compounds like benzaldehyde, this compound also does not have alpha hydrogens. So, this is forming benzyl alcohol, a reduction product, sodium benzoate, an oxidation product. In this also, if you take only one particular compound without alpha hydrogens, it is called Cannizzaro reaction. If we take two different carbonyl compounds without alpha hydrogens, we call that as crossed Cannizzaro reaction. Okay. So, now a question that came in NEET 2020. Okay. So, the question is reaction between benzaldehyde, a carbonyl compound without alpha hydrogen, and acetophenone, that is acetophenone compound with alpha hydrogens treated with a dilute base. Okay. Dilute base. So, it is aldol. Which aldol condensation? It is a crossed aldol condensation, because it is taking place between the two different carbonyl compounds. So, the answer is 1, crossed aldol condensation. Okay. Next, haloform reaction. This is also very important reaction. Compounds that contain acetyl group, okay, compounds that contain acetyl group react with any of these reagents, like a halogen in sodium hydroxide, or halogen with potassium hydroxide, or calcium oxychloride, they form haloform, that is chloroform or bromoform or iodoform. Now, this is the acetyl group is a prerequisite to undergo the haloform reaction. But isopropyl alcohol or ethyl alcohol, if you observe, we can't see or we cannot find out here the acetyl group, but during the course of reaction, ethyl alcohol will oxidize to acetaldehyde that contain acetyl group. Isopropyl alcohol will oxidize to acetone that also contain acetyl group, and these ethyl alcohol and isopropyl alcohol can also undergo haloform reaction. Okay. So, here we have a question, which of the following will not give iodoform, that is haloform, on reaction with iodine and sodium hydroxide. So, here you see ethanol can give, because during the course of reaction it will convert to acetaldehyde. Propanol will convert to acetone during the course of reaction. Okay. Butan 2-one CH3, C double bond O, CH2 CH3. Butan 2-one also has acetyl group, but methanol cannot undergo this haloform reaction, cannot form iodoform. Okay. So, the answer is 1 for this question. Okay. Next, Hell-Welhard-Zielinski reaction, a very interesting and important reaction. Here carboxylic acids having alpha hydrogens, when treated with halogen in presence of red phosphorus, alpha halogen is substituted by alpha hydrogen is substituted by halogen, and you get alpha halocarboxylic acids. Okay. This is called HVZ reaction. Next is an interesting reaction, Gabriel's thalamide synthesis. It is a method to prepare primary amines. It is a very interesting and important reaction. In this reaction, thalamide is treated with potassium hydroxide, it will form a salt. When it reacts with alkyl halide, there takes place nucleophilic substitution reaction. This is acting as the nucleophile, substitutes halogen, you get alkyl thalamide. This alkyl thalamide on treatment with sodium hydroxide, we get primary amine. You can prepare primary amines by this reaction. Another important point is, we cannot prepare aryl, aryl halides cannot be they cannot participate in this reaction. Why? If you take chlorobenzene or if you take bromobenzene, they cannot undergo nucleophilic substitution reaction easily. Therefore, you cannot prepare aryl, you cannot use aryl halides in this particular reaction. Okay. Next, Hoffman bromide degradation. In this reaction, we are taking an amide, treating with bromine KOH, we are getting amine that contains one carbon atom less than the starting amide. Say for example, if we start with ethanamide, 2 carbon containing amide, you get 1 carbon containing amine. We get 1 carbon containing amine. You may get questions on this particular reaction also. It is a very one of the important reactions. Okay. Carbylamine reaction. It is a reaction which is useful to detect primary amines. Okay. Primary amines will give this particular reaction. Okay. If you take a primary amine, treat with a mixture of chloroform and base KOH, you will get alkyl isocyanides, which are very foul smelling compounds. Okay. Very bad smelling compounds, very poisonous compounds, and these are formed. It is a test to identify primary amines, whether it may be aliphatic or aromatic. Okay. So, here he gave a question in we got a question NEET 2020, simple question, which of the following amine will give carbylamine test? Primary amines will give. Among these, which is the primary amine? Option 2 is the primary amine. So, option 2 aniline will give, that is answer 2 is that compound will give carbylamine test. Okay. Next, Sandmeyer reaction. Okay. In this reaction, it is a method of preparation of aromatic halides or cyanides from benzene diazonium halide. Okay. Here you can observe the reaction, benzene diazonium chloride on reaction with copper chloride HCl or copper bromide HBr or CuCN KCN, that is cuprous chloride or cuprous bromide or cuprous cyanide in presence of HCl or HBr or KCN, we will get chlorobenzene, bromobenzene or cyanobenzene. If you want to prepare iodobenzene, this is treated with potassium iodide, then we get iodobenzene. Okay. Next, Gattermann reaction. Through this reaction also we can prepare chlorobenzene or bromobenzene. Here benzene diazonium chloride treated with copper HCl or with copper HBr, we get chlorobenzene or bromobenzene. See, there is one more similar reaction called Gattermann-Koch formylation. In that reaction, benzene is treated with carbon monoxide HCl in presence of AlCl3 and the product is benzaldehyde. So, in Gattermann reaction, we prepare chlorobenzene or bromobenzene. In Gattermann-Koch reaction, it is a method of preparation of benzaldehyde. Okay. Now, we have a question on this. NEET 2023. Identify the product in the following reactions. final product is asking. He has started with benzene diazonium chloride. So, he has treated with Cu2Br2. So, initially we get bromobenzene. Bromobenzene is treated with magnesium and dry ether. So, you get a Grignard reagent, phenyl magnesium bromide. We get phenyl magnesium bromide on hydrolysis will give benzene. Okay. So, the answer is fourth option is the right option.